Hey guys, in this video we're going to learn how to define your variables in a word problem, then translate the situation into an equation, and then eventually solve that word problem. So example 1, let's define our variables in the following situation. So all we have to do right now is define what our variables are. So it says, Miss Lippy likes to drink 3 times as many cups of coffee as Carl does. If Carl drinks 2 cups of coffee today, how many cups will Miss Lippy drink? Okay, so it's a word problem, and a lot of us would like to jump to conclusions and try to figure out what the answer is. However, all I want you to do is define what your variables are. Alright, so in this problem we're talking about one person, Miss Lippy, who drinks cups of coffee. Okay, we also know there's another person involved named Carl who drinks cups of coffee as well. So the two variables that we're talking about, I know that it says Carl drinks 2 cups of coffee, but the two variables will represent the two main objects in our situation. So we can say, when we define our variables, is x equal to, as specific as we can, the number of cups Miss Lippy drinks, or drink. Okay, that's what x represents. Don't just write down cups of coffee, don't write down Miss Lippy. It's the number of cups Miss Lippy drink. So then our second variable involves our second person, who is Carl, and then y would equal the number of cups Carl drank. And that's all you have to do. Okay, so whenever you read a word problem and you're trying to figure out the answer, always identify your variables. Okay? So let's look at B. This year, Randy and his son Stan are in charge of selling Lord tickets. VIP tickets are $74.39 each, and standing room only tickets are $45.29 each. The total amount of money collected was $32,994. Randy remembered selling exactly 200 VIP tickets. How many standing room tickets or standing room only tickets did Stan sell? Alright, so then we have two people doing two things. The first person we're talking about is Randy, who's selling VIP tickets. Okay, so we can say that each VIP ticket is $74.39, and then standing room tickets are $45.29 each. So we know the price per ticket, but we don't necessarily know how many tickets were sold for each. So then our first variable would be x equals to the number of VIP tickets sold. Okay, so then the second variable that we're going to use represents the standing room only tickets. Okay, going back a little bit, we do know that it gives us that Randy sold exactly 200 VIP tickets, but if we didn't know that, we would still define what our variable would represent. Okay, so then going back to our second variable, we can use y, and that would represent the standing room only tickets, the number of them. Okay, so as much as possible, be as specific as you can when you define your variable so you know what it means. In example 2, we have to define our variables and translate the situation into an algebraic equation. The 347 students who listed soccer as their favorite sport were 13 less than 3 times the number of students who listed basketball as their favorite sport. Okay, so we have to translate it, we have to define it and then translate it. So we have to define our variables. So we know that we're talking about students and their favorite sports. Well, the two sports we're talking about are soccer and basketball. So we can say the first variable, x, would be the number of students who listed soccer as their favorite sport. And the second would be number of students who listed basketball as their favorite sport. So then x equals the number of students who listed soccer, which was actually 347. And then the number of students who listed basketball could be your y variable. Notice how specific we're getting with the variables. We're not just writing down basketball. We're not just writing down soccer. Okay, so then we know the exact number of students who listed soccer, and we don't know the number of students who listed for basketball, but then we just wrote this number on the side to know that we actually know that value. Now we have to translate that situation. Since we know that we've already defined it, let's translate it. So we're looking at the number of students who listed as their favorite sport were, so that were is your equal sign. Okay, so then this variable, the people who listed soccer as their favorite sport, equals 13 less than 3 times their favorite sport. Or 13 less than 3 times the number of students who listed basketball as their favorite sport. So when we translate that equation, or that sentence into an equation, we take our variable that represents the people who voted soccer as their favorite sport, x, equals is the were. Now 13 less than, remember we flip-flop the order, so 3 times the number of students who listed basketball, so that would be 3 times y, and then 13 less than that would be minus 13. Okay, so this represents the number of students who listed soccer as their favorite sport were 3 times the number of students who listed basketball as their favorite sport, but 13 less than that. That would be our answer translated. So then second example for 2, we have to do the same thing. Miss Mary Samsonite moved to Colorado for 2 reasons: to buy snow owls and to go skiing. Each snow owl is $232, and each day of skiing costs $15.99. Mary spent $3,079.96 and went skiing for 4 days straight. How many owls did she purchase? Okay, so we're talking about 2 things: Mary going to Colorado to go skiing and to buy snow owls. So we know each snow owl is $232, and we also know that each day of skiing costs $15.99. So those are our 2 variables right now. X is the number of snow owls purchased or bought, and then Y would be the each day, or the number of days that Mary skied. Okay. Now total, she spent this much money, $3,079.96, and we do know for a fact that she went 4 days skiing. Okay, to represent this situation, Mary going to Colorado and spending this much money either buying snow owls and skiing, well, we know that that price, so we have each day, so that the things that she did, she either bought snow owls or she went skiing. So she spent $232 for each snow owl, so 232 times X, plus the number of days of skiing, so we don't know that for now, $15.99 per day of skiing, and that sum would equal $3,079.96. So that situation in this problem here is represented by this equation. I know that we know the number of days she skied, but just to translate what's happening to an algebraic equation is right here. Alright, so in the previous examples, we didn't have to solve anything. We didn't have to find out what the answer is until now. So in this equation, in this example, we have to define our variable, translate the situation into an algebraic one, and then also solve it. So let's first define our variables. It says John and his wife Angela, aka Johnjula, have to buy diapers and containers of baby food for their newborn daughter Ava. Their budget for the month is $350. A box of diapers of $50 each and a container of food is $1.39 a piece. If Johnjula buys 90 containers of food, how many boxes of diapers can they buy? So instead of just trying to answer the question right away, let's define our variables. So we're talking about 2 people who are buying baby food and diapers. So the box of diapers is $50 each and a container of food is $1.39 a piece. So we know how much each item is, but we don't know how much of each item we bought. So our first variable, X, would be the number of diapers, or number of boxes of diapers, and Y would be the number of containers of food, which in this case we actually know that is 90 containers because that's what they give us. Okay. Now their budget is $350, so then we have to make a combination of the fact that we bought a certain amount of diapers and a certain amount of containers of food to give us $350. Okay, so 50 times the number of boxes of diapers, because 50 would represent the price per box, and then plus $1.39 per container of food. Whatever this adds up to, it has to equal $350 or cannot go over it. Okay, so the maximum number of diapers that we can buy, well, we know that they gave us that Johnjula bought 90 containers of food. So we have 50x plus 139 times 90 containers of food equals 350. So when I buy 90 containers of food, I actually spend $125.10, and then I solve for x. So I subtract 125.1 from both sides. That zeroes out, so 50x equals 224.9. Divide both sides by 50. And then x equals 4.498. So you can't actually buy 4.498 boxes of diapers. So we have to round down to exactly 4 boxes of diapers. Okay, so keep in mind we have to define our variables first, translate the situation, and then solve it. So that's your thought process whenever you read a word problem that involves variables and more than 3 sentences in your problem. Alright, so if you have any questions, make sure you write them down, and then we can ask and go over this the next day. Have a good day.